Hello, once again, ladies and gentlemen. Welcome to our virtual classroom. Let's go ahead and begin. Today, we are working on our review for our exam. And I know I said to some of you guys that the exam would be on Tuesday, but it's actually going to be on Wednesday. You will find this exam on Monday's folder. Monday, it just says review fall semester CBA. Just click start new attempt. And that's how you will get to the exam. By the way, today I'm only going to be going over the following questions. I'm going to be going over numbers 1, 2, 3, 6, 8, 9, 10, 11, and then 12 and 14. So those are the ones that I'm aiming to get through right now. Okay, 1, 2, 3, 6, 8, 9, 10, 11, 12, 14. I recommend that you write these on your notebook. There is a spot for you to upload a picture of your work on OneNote. And so with that in mind, let's go ahead and begin with number 1. I do recommend that you pause this video at any point if you need to write something down to catch up. So it simply reads, which expression is equivalent to 6 or parentheses 6 times 2 divided by 3 plus x? So in other words, which of these three really is the same as this top expression? What I would do, ladies and gentlemen, is I would call to mind the order of operations, which is PEMDAS. Parentheses, exponents, multiplication and division, and then addition and subtraction. That's PEMDAS. Now, please remember that you always do what's inside the parentheses first, and then whatever's inside the parentheses, you do the exponents first and division, multiplication, addition, subtraction, right? So that's the way you would work that out. However, once you finish what's inside the parentheses, then you do exponents for sure. And then remember multiplication and division, the order matters a lot. All right, so if you have multiplication and division, you always go first come, first serve from left to right. So whatever comes first, going from left to right. If you see division first, you do that first. If you see multiplication first, you do that first. And then finally, you move on to addition and subtraction. Same thing, first come, first serve. If you see subtraction before addition, you do that first. If you see addition before subtraction, you do that first. All right, so here, ladies and gentlemen, want to see which of these is the same as this. Notice that we first have to do the parentheses, and inside the parentheses, we have both multiplication and division. Remember, first come, first serve. So I would first have to do 6 times 2 and then divide that by 3. So which of these is telling me to do that first, 6 times 2, and then divide that by 3? Well, if I look at A, I have to follow PEMDAS. It's telling me to do 2 divided by 3. I'm sorry. Is that the same thing as multiplying 6 times 2? It's not. Clearly, it is not. So definitely the answer is not A. Let's look at B. X plus 6 times 2/3. At first glance, it doesn't look anything like this top one, except that we are multiplying first. But remember that division is that fractions are the same thing as division. So this really is the same thing as x plus 6 times 2 divided by 3. And when I write it in this form, ladies and gentlemen, notice that I have addition, multiplication, and division. Again, division and multiplication always come before addition, and multiplication comes here before I go to the division. Notice that I am multiplying the 6 times 2 first. Good. After which I would have to divide by 3. So I'm going to put that as a maybe. That seems to be the right answer, but let me check my other one first. Now on this last one, we have 2 parentheses, so let me do the first one first, and it tells me to add 6 and x. At any point, am I adding 6 and x up here? No, ladies and gentlemen, the only one that makes sense is B. So again, the order of operations. That is precisely what I want you to focus on right here. Let's move on to the next one. And if I went too fast, pause it, go back and look at it. It says, which situation can be represented by the equation y equals to 5x? Y equals to 5x. Ladies and gentlemen, when I have a letter next to a number, a variable next to a number, that always means multiplication. That means 5 times x. So that is going to equal to y. Let's see which of these situations has multiplication where you're multiplying something times 5. A, Jose has X pair of shoes. Okay. This is 5 times Y, the number of shoes his sister has. So Y is the number of shoes his sister has, but it's saying that I need to do 5 times Y. Am I at any point multiplying 5 and Y up here? I am not. So ladies, A is clearly not the answer. Let's go to B. Let's go to B. Jose takes Y minutes to get ready in the morning. This is 5 times X, which is the number of minutes it takes Jose's sister to get ready. 5 times X, 5 times X, 5 times X to get Y. That seems to make sense. Check mark. C. Check mark because that might be the answer. Okay, I want to read all of them first though. C. Jose bought a sweater for X dollars. He gave the cashier Y dollars and received $5 in change. So that's to say that he gave the cashier Y dollars and he gets back X dollars, and then that's equal to $5 in change. That's subtraction, ladies and gentlemen. Anytime you're getting change or seeing the difference between two things, or like literal money change, like how much money you would get back, that's usually subtraction, maybe addition. Regardless, that's definitely not multiplication. The answer is not C. And finally, D, Jose is Y years old. His age is 5 years greater than X. When something is greater than, it's just addition, right? So that's not it, ladies and gentlemen. The answer is B. Again, we just saw what operation we're doing. We're doing multiplication, and we saw which of these ones shows as multiplication in the right way, and the answer was B. Let's see that in number 3. Number 3 is actually very similar to this. The equation 30G, or 30 times G is equal to 150, represents which situation? Notice that once again, I have multiplication. We have 30 times G, whatever G is going to give us 150. Let's go ahead and do it one at a time. Anna read 150 pages of a book each of G days. In other words, she's doing 150 on day 1, and then she's doing that over and over again, 150 again, 150 again. It seems to me that you're multiplying 150 times over and over again. However, over here, we're actually multiplying 30 times something over and over again. So that doesn't seem to make sense to me, guys. It seems like we're repeating 150 as opposed to up here where we're supposed to be repeating 30 over and over again. That's what multiplication is, right? Doing the same thing over and over again, a certain number of times. In this case, we're definitely not doing that in A. So A is not the answer. B. Anna read 30 pages in a book each day for G days. So she's doing 30 and 30 and 30 and 30 each day. I don't know how many days, but she's doing that over and over again until she read 150. That seems very likely. 30 times G, a certain number, equals to 150, the total pages that she read. That sounds very similar to what I have up here. Let's look at the next one. Anna read 150 pages of the book yesterday. So she starts off with 150. The book is G pages long, so that's the total pages that the book is. How many pages is the book? How many pages long is the book if she read 30 pages each hour? So it seems that after those 50 pages, she's reading 30 pages each hour. I'm kind of confused. Or maybe, again, it's just there's a lot more going on than just 30 pages times the number of days equals to 150. So I'm going to say no to that one. And then finally, D, Anna read 30 pages of a book today. Okay, so she read 30. It will take her G days to read the rest of the book. But again, it's not telling us that we're reading 30 pages each day. It's just telling us that it's going to take us another set of pages to read the whole book. We don't know how many pages she's reading each day, so I can't assume that she's doing 30 today, 30 tomorrow, 30 the day after that. So ladies and gentlemen, the only one that clearly makes sense is B. This one was a little confusing, but we followed the same process. Which one of these is telling us that we're starting with 30 and we're doing that over and over again to get to 150? The answer is B. All right, we'll go over 4 tomorrow, and we'll go over 5 tomorrow. Let's go to 6. Which number would be located in the shaded part of the diagram? Notice, guys, that I have in this diagram, it says integers. So everything inside this diagram is going to be integers. Everything inside of it will be an integer. And notice that inside this integers, we have another group, which is the whole numbers. Meaning that if you have a whole number, it is also an integer. What do I mean by that? Well, let's recall what an integer is. Remember, an integer is simply a number without a decimal value. So 7 is the same thing as 7.0 because all numbers have decimals. It's after the ones place. Even if you don't see it, we need to remember there is a decimal, but however, there's no value following it. It'd be 7.000000. It's just 7. That we just say 7 because there is no decimal value. Something like -81. Again, it does have a decimal, but there's no value following it, right? So -81 and -81.0 are the same thing. It's just that one of them is showing that there is no decimal value. Guys, both of these, positive or negative, they're integers. However, a special kind of integer is a whole number, which is a positive integer, like the number 7, like the number 10, right? And so an integer would be like the number -81, like the number -8, because again, no decimal value. However, it's not positive, so I can't call it a whole number. All right. So whole numbers are special integers, but these are all integers, all of these numbers right here. So let's go one by one. A, -1.7. It has a decimal value. It is not an integer. Remember, integers do not have decimals. -1.7 does have a decimal. Just like 1.7, again, decimal, not an integer. Okay? Whether it's positive or negative, it is not an integer. B, -8. Check, because that is an integer, definitely an integer. And it's not a whole number because it is not positive. So -8 is definitely an integer. It would go in the shaded portion. C, 2/3. When you have a fraction, guys, it's important to remember that fraction means division. For example, if I have something like 6/3, I can't just be like, oh, that's a fraction because 6 divided by 3 is the same thing as 2. And that doesn't have a decimal value. So this would be considered an integer. But 2/3, notice that if this was a pizza, I only have 2 out of 3 pieces. It's not even one whole. It's going to be a decimal. And if you don't believe me, remember that this means division. 2 divided by 3 is going to give me 0.666666. So obviously it has a decimal value. Ladies and gentlemen, 2/3 is not an integer. And 10 is an integer. However, it's a special integer. It's a whole number. So it wouldn't be in this shaded portion. It would be inside of that shaded portion. So ladies and gentlemen, the one that makes the most sense is B. B. Remember, integers, we have negative integers, and then we have whole numbers, which are the positive integers. And that's pretty much it. Here was asking what is an integer that is not a whole number. The only one that really fit that description was B, which is -8. Please watch this again. Watch this part again if you found that confusing, okay? Let's move on. We'll come back to number 7 later. Number 8, ladies and gentlemen, the grid. Please remember that a grid has 2 axes. We have the x-axis, which is the horizontal axis. That's the x-axis. And then we have the vertical axis, which is the y-axis. That would be the y-axis, right? So that is the y-axis. We have x-axis, we have y-axis. Remember that there will always be whenever there's a point, that point will always have two coordinates. One of them is going to be an x coordinate telling you how much to the left or to the right that number is going to go. And then there's a y coordinate, which tells you how much up and down that number is going to go, right? So for example, if you look at letter K right here, we have to start at 0. And letter K, first we do the x. The x value is going to be -1, -2, -2.5. It's halfway, right? So it would be 2.5 or 2.5. And then my y value, we go from here, we go 1, 2, 3. It's +3. So we went -2.5, negative because we went to the left, and then we went up 3. So that would be my value of K, -2.5, and then 3. Now, if I looked at letter L, so this is K right here. If I looked at L, for the X, we start at 0. We go 1, 2, 2.5. This one is +2.5. And then from there, we go not down, so it's not negative, but up. So my y is going to be +1, 2, 3. So notice the difference. K, the coordinates are -2.5 because it went negative in the x, and then +3. And the L was +2.5, and then we went +3. So that's how the coordinates work. So which point best represents the ordered pair -2.5, -2.5, 3? Well, we already have it right here. That would be K, which is B. All right. So hopefully that's just a review. I'm not going to spend too much time on that. All right. So ladies and gentlemen, this is going to be part 1. There's going to be a second part to this video. So this will be part 1 of the review. And then I don't want this video to be too long. I'll continue with numbers 9, 10, 11, 12, and 14 on part 2 of the video. And so I will see you soon again, ladies and gentlemen.